Okay, so now we're going to talk about exponential decay. So with exponential decay, same thing where we want the variable and the exponent, but in this case, we call this the base of the exponent. So if the base of the exponent is between 0 and 1, meaning it's a fraction, right, that's where we're going to get exponential decay. And the reason we call it decay is that, as you'll see when we graph this, as we move from left to right, the y values are actually going to go down or decrease, unlike where we had the exponential decay. So just like before, when we're trying to create a graph, let's pick some points for the x values, calculate out the y values, and graph. So let's start with 0. 1/2 to the 0, or anything to the 0, is 1. 1/2 to the 1 is just 1/2. 1/2 to the 2, so let's come over here and do this. So 1/2 to the second power is just 1/2 times itself, so 1/2 times 1/2. So multiplying fractions, we go straight across, we get 1/4. And then if you do the same thing, 1/2 to the third, so 1/2 times itself 3 times, you would get 1/8. So let's start to now plot these points. So 0, 1 would be here. 1, 1/2 would be here. 2, 1/4 would be here. And then 3, 1/8. So as you notice, we're kind of getting closer and closer to 0. So now let's try these two numbers, the negatives. So 1/2 to the -1. So remember, if I have a fraction to a power, I want to distribute that exponent to each thing. So 1 to the -1 divided by 2 raised to the -1. Right, and then how to deal with the negative exponents, we flip where they're currently at. So the 2 to the -1 goes to 2 to the +1 in the numerator. 1 to the -1 goes to 1 to the +1 in the denominator. So 2 to the 1 is just 2. Over 1 to the 1 is 1. So we get 2. So -1, 2. Okay. And then if we do the same thing, plugging in -2, so 1/2 to the -2. So distribute 1 to the -2 over 2 to the -2. So we get 1 to the 2 over 2 to the 2. So 1/4. Oh, sorry, I messed that up. So I forgot to switch. So if it's 2 to the -2, that becomes 2 to the +2 in the numerator and 1 to the +2 in the denominator. So we get 4/1, or 4. Okay, so now let's plot those points. So -1, 2, we already plotted, and then -2, 4 goes here. So your graph is going to start to look something like this. Right, so similar in shape to the exponential growth, but going in the different direction as we move left to right. Again, the numbers are now going down. The y values are increasing as we're moving from left to right. Okay, and then similar to exponential growth, if we throw a number out in front of the 1/2 to the x, we call this a vertical stretch. So if I throw a 2 or a 3 or a whole number out in front, right, the original graph is going to get stretched to something like in blue. Now if I throw a fraction out in front, it goes the other way. We call this a vertical shrink. So if it's a whole number or a number bigger than 1, we call it a stretch. If it's a fraction out in front, we call it a vertical shrink. Right? And then this number, the base of the exponent, again, is called the either growth factor or decay factor. This is a decay factor since it's exponential decay.